first, I've created a function called cow surface area, um, which obviously must contains three float arguments: A axis radius par, B axis radius par, and C axis radius par. So the function is cow underscore value A, B, and C. And this function basically must return the surface area calculation based on the formula, which is the volume equals 4 over 3 times pi times A times B and times C. Uh, and in that case, A and B and C are the axes of the ellipsoid as well. Okay, so now I'm just going to test different cases to prove my code works with various numbers. So for instance, I did 3.0 as the A-axis radius, 4.0 for the B-axis radius, and 5.0 for the C-axis radius. And the volume I get is 251.327, and the number can go on. And let's try another. Mm, 0, 3.0, and 4.0. As you can see, I get a different volume as well. So in my program, I needed to use a constant pi to calculate the volume of an ellipsoid. And instead of manually typing out the value of pi, I use a Python's math module, which gives a more precise value of pi. So to do this, I first imported the math module at the beginning of my program using the line math import. After importing the math module, I then use mathpi to get the value of pi when calculating the volume of ellipsoid. And as I said previously, replacing the pi symbol with the math dot pi ensures my calculations is accurate value of pi instead of an approximation. And here's how I did that in my code. Mm, okay. Using the math.py code makes using the math.py line makes the code not only cleaner, but also more precise. And then the difficult part was the debugging issues and figuring out how to structure the functions in the first place. But when I watched the video of the instructions, it made sense, and I was able to execute. The easy part was understanding the mathematical formula and setting up the basic input and output structure. And then to summarize it, I created a program to calculate the volume of an ellipsoid using the formula volume equals 4 over 3 times pi times A times B times C. And yeah, so I will, let me do this. You can with the actual approximations. 2.1, 2.2, and 3.3. And that is something I've been experiencing. My surface area is incorrect, but my volume is correct. So I'm not really sure where I'm going wrong, but I have to go over this and see what I've done.